Parts of an atom. So an atom is made up of three subatomic particles. We have the nucleus, which have a larger concentration of positive and negative charges, and around it are whizzing around the electrons. So here's the chart that shows the subatomic particles. The protons, which are in green, have a positive charge and a mass of 1. The neutrons are also in the nucleus, and they have a charge of 0. They have no charge. Then you have the electrons that are whizzing around. Now, some textbooks say that they have no charge. They actually do, sorry, they don't have a mass. They do have a mass. It's 1/1000th the mass of a proton or a neutron. I tend to think of them as eyebrows. In other words, they have mass. You can feel them, you can touch them. But when you're talking about the mass of an electron relative to the mass of a proton or a neutron, whether they're there or not really isn't going to change the overall mass of the atom itself. So with charges, we're going to be concentrating on charges. We're looking at the protons and the electrons because those are the only subatomic particles that are charged. So if I have an equal number of protons and electrons, then I have a neutral charge. The two charges balance out. If I have more electrons than protons, I have a negative charge. And if I have more protons than electrons, I have a positive charge. What's important to notice is that because the electrons are so light and they're on the outside, like eyebrows, they're easy to add or to remove. So only the electrons can move. I can't transfer any protons. If I transfer protons, it's a nuclear change. That's something that's really difficult to do. So only electrons can be transferred. When I say that they're transferred, that means that something loses electrons and another thing gains those electrons. The number that I lose is exactly the number that I gain. I can't have electrons just sort of like floating around. That's the conservation of charge, right? So when something loses the electrons, it becomes positively charged, and the thing it loses electrons to becomes negatively charged, right? So if something loses 3 electrons, the other thing has to gain those 3 electrons. And how easily those electrons are transferred is listed on the triboelectric series. So the triboelectric series is basically comparing two objects with one another so that when I rub them against one another, one of them will have a tendency to grab the electrons, the other one will have a tendency to lose the electrons. The thing that grabs the electrons becomes negatively charged, the thing that loses the electrons becomes positively charged. And the farther they are apart on the triboelectric series, the more that transfer will happen. So an example would be if you're walking across a carpet, the shoes will tend to gather the electrons off of the carpet. The carpet will become positively charged. You and the shoes will become negatively charged. So there's that transfer of electrons. If I just have bare feet on a carpet walking across, the difference between those two objects isn't as great. So I'm not going to have problems with static as much if I'm wearing bare feet versus if I have shoes on.